Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. And continuing with this coordinate geometry, we have derived the section formula in our previous lesson. That is, x coordinate is equivalent to m1 x2 plus m2 x1 divided by m1 plus m2, and y coordinate is given by m1 y2 plus m2 y1 divided by m1 plus m2. So we have already discussed that this section formula is utilized to find the coordinates of the point which divides the line segment into two sections or three sections. Intersections simply we can call it. So this P, if AB is a line segment and this is divided in some ratio, say 1:2 by this point P. Suppose the coordinates of this point P be x and y. Now this x is given by m1 x2 plus m2 x1 divided by m1 plus m2, and this y coordinate is given by m1 y2 plus m2 y1 divided by m1 plus m2. And similarly, we have already discussed it if two sections are equal, that is, this section is equal and this section, that is ratio is equal, m1 is equal to m2, then obviously this x coordinate is given by x1 plus x2 by 2, and y coordinate is given by y1 plus y2 by 2. That is when the two sections are equal. Now the questions relating this section formula. Question number 1 reads, find the coordinates of the point which divides the join of points. Suppose let this be A and B. A has coordinates -1 and 7, and this B has coordinates 4 and -3. And you have to find the coordinates of the point which divides this line segment in the ratio of 2:3. So this is P. Let the coordinates of this point be x and y, and the ratio is 2 and this is 3. That is, AP is equal to 2 and PB is equal to 3. Now this is very simple. Here x1 is equal to -1 and x2 is equal to 4. y1 is equal to 7 and y2 is equal to -3, and m1. So x1 is equal to -1 and x2 is equal to 4. y1 is equal to 7 and what is y2? It is -3, and m1 is equal to 2 and m2 is equivalent to 3. So easy now. X is equivalent to m1 x2 plus m2 x1 divided by m1 plus m2, and y coordinate of this point is equivalent to m1 y2 plus m2 y1 divided by m1 plus m2. So x is equivalent to m1 is 2, and what is x2? It is 4, plus m2 is 3, and x1 is -1 divided by 2 plus 3. m1 is 2 and m2 is 3. Similarly, y is equal to m1, it is 2, and y2 is -3 plus m2 is 3 into y1, it is 7 divided by m1 is 2 plus 3. So here x is equivalent to 4s are 8 plus -3 1s are 3 divided by 5, and y coordinate is equal to 2 3s are -6, 7 3s are 21 divided by 5. So x is equal to 5 divided by 5, and y is equal to 15 divided by 5. 5 and 5 cancels, left with 1. 5 1s are 5 3s are. So x is equal to 1 and y is equal to 3. So the coordinates of this point P are 1 3. This is very simple. By employing this section formula, you can find the coordinates of the point that divides the line segment into sections. Similarly, question number 2 reads, question number 2, find the coordinates of the point of trisection of a line segment joining, suppose it's a point, it's a line segment AB, which coordinates A has, let A 4 and -1, and B has coordinates -2 and -3, and this line segment has been trisected. Trisected means that it is divided into 3 equal parts. Suppose this is P and this is Q. AP is equal to PQ is equal to QB. All sections are equal. Now, this AB has been trisected. Suppose P, this is one section AP, and PQ is second section, and QB are, these are equal sections. So let the coordinates of PB x1 y1, and let the coordinates of QB x2 y2. So easily applying the same section formula, let's find the coordinates of this point P first. Here, what is AP? This is 1, and what is PB? This is 2. From P to B, these are 2 sections, so obviously M1 is 1 and M2 is equivalent to 2. When we find the coordinates of point Q, then AP is equivalent to 2 and this QB is equivalent to 1. So here x1 is equal to 4, x2 is equal to -1, y1 is equal to -2, and y1 is equal to -1, x1 is equal to 4, and x2 is -2, x2 is -2, and y1 is -1, and y2 is equivalent to -3. M1 is equivalent to 1, and what is M2? It is 2. So first we have to find the coordinates of this point P. Obviously this section is equivalent to 1, and from P to B there are 2 sections, so M2 is equivalent to 2. So here x1 is equivalent to same section formula M1 x2 plus M2 x1 divided by M1 plus M2, and this y1, see this y1 is equivalent, that it will be capital X1 and this capital Y1. So this is M1 Y2 plus M2 Y1 divided by M1 plus M2. So this X1 is equivalent, M1 is 1, very easy, and what is X2? It's -2, plus M2, what is M2? M2 is 2, and x1 is 4 divided by 1 plus 2, because M1, this M1, AP is 1 and PB is 2. Similarly, this Y1 is M1, it is again 1 into Y2 is -3 plus M2 is 2 into Y1 is -1 divided by 1 plus 2. So here we go. X1 is equivalent to -2 plus 8 by 3, and this Y1 is equivalent to -3 -2 divided by 3. So X1 is equivalent to 6 by 3 and -5 by 3. Okay. This is Y1 is equal to -5 by 3. So X1 is equivalent to 3 1s are 3 2s are 2, and Y1 is equivalent to -5 by 3. So these are the coordinates of this point P. Now, to find the coordinates of point Q, so here again, this x1 is equivalent to 4, x2 is equivalent to -1, x2 is equal to -2, and y1 is equivalent to -1, y2 is equivalent to -3, and m1 here, m1 is equal to 2 and m2 is equivalent to 1, because from A to Q these are two sections, so M1 is 2, and from Q to B there is one section, so M2 is 2. So here x2 capital X, let it be M1 x2 plus M2 x1 divided by M1 plus M2, and Y2 is equivalent M1 Y2 plus M2 Y1 divided by M1 plus M2. So x2 is equivalent M1, here it is 2 now. 2 into x2 it is minus 2, plus M2 is 1 into x1 is 4 divided by 2 plus 1. Similarly, Y2 is equivalent M1 is 2 into Y2 is minus 3 plus M2 is 1 and Y1 is minus 1 divided by 2 plus 1. So here x2 is equal to minus 4 plus 4 divided by 3, and Y2 is equal to 2, 3s are minus 6 minus 1 divided by 3. So very simple, x2 is equal to 0, 4 minus 4 is 0 by 3 is 0, and Y2 is equal to minus 7 by 3. So these are the coordinates of this point Q, 0 and minus 7 by 3. So that is how it goes. It's very simple. Now question number 3, readers. Find the ratio. Now you have to find the ratio in which the line segment is divided. Minus 3, 10 and 6 minus 6 is divided by. So point of division is this time given. This point of division is given. And let it be A and B, this line segment having coordinates minus 3 and 10, and B has coordinates 6, minus 8, and the coordinates of this point of division is already given. This one, that's x is minus 1 and y is 6. We have already learned that this section formula is used to find the point of this point which divides the line segment into sections, but x coordinate is given and y coordinate is given, so this is very simple, let it be P. But we have to find the ratio, that is M1 and M2. Let M1 be K. When ratio is not given, let it be K is to 1. M2 is M1 is equal to K, let it be. Let the ratio in which the line segment is divided, let the ratio in which the line segment is divided be K is to 1. So here x1 is equal to minus 3, and what is x2? It is 6. Y1 is equal to 10, and y2 is equal to minus 8. And what is here M1? So supposition that M1 is equal to K, and what is M2? It is 1. Now this x is equivalent M1 x2 plus M2 x1 divided by M1 plus M2, and y coordinate of this point is given by M1 y2 plus M2 y1 divided by M1 plus M2. So here we go, x is equivalent. So what is x here? It is minus 1. So minus 1 is equivalent M1. M1 is K into x2, it is 6, plus M2, what is M2? It is 1, into x1, it is minus 3, divided by K plus 1, because M1 is K and M2 is 1. Similarly, and y, it is equivalent to 6 is equivalent, M1 is K, into y2, it is minus 8 plus 1, M2 is 1, into y1 it is 10 divided by K plus 1. So let's solve this. Minus 1 is equivalent to 6K minus 3 divided by k plus 1 by cross 6k minus 3 is equivalent minus k minus 1. So taking k to this side, 6k plus k is equal to minus 1. So this is plus 3 obviously. This is 7k is equivalent to 2. What is k? It is 2 by 7. So k is equivalent to 2 by 7. Our ratio was k is to 1. So this is 2 by 7 is to 1. So this is 2 is to 7. So this is the ratio. 2 is this line segment has been divided and the ratio of 2 is to 1. Similarly, if you solve this, again you will find that it is k 2 is to 7. The ratio will be the same. So it is simple that when ratio is not given, you will put it k is to 1. Then find the value of k. So these are simple questions. Now proceeding further, question number 5, find the ratio in which the line segment A 1 minus 5 and B minus 4 or 5 is divided by x-axis. Find the coordinates of the point of division. Again the same question. Suppose this is A with coordinates 1 and minus 5 and B has coordinates minus 4 and 5, and this is divided by this x-axis. So x coordinate is there and y is 0 obviously because it is divided by x-axis. So x0 is the coordinates of this point of division. And what is the ratio? Let again it be k is to 1. So you have to find the ratio again in this question. Now simply here again x1 is equivalent to 1 and x2 is equivalent to minus 4, y1 is equivalent to minus 5, and what is y2? y2 is 5, and m1 is k and m1 is k and m2 is 1 by virtue of our supposition. Again this x is equivalent m1 x2 plus m2 x1 divided by m1 plus m2. Similarly this y is equivalent m1 y2 plus m2 y1 divided by m1 plus m2. Here x is x is equal to m1. What is m1? It is k into x2 is minus 4 plus m2 is 1 and x1 is 1 divided by k plus 1. And what is this y coordinate? Is 0. So 0 is equivalent to m1. Again this is k into y2 is 5 plus m2 is 1 into y1 is minus 5 divided by k plus 1. Let's solve this. Or simply x is equal to minus 4k plus 1 divided by k plus 1. Leave it here. So here we get 0 is equal to 5k minus 5 divided by k plus 1 by cross 5k minus 5 is equivalent to 0 because multiplication, when you multiply anything by 0 is equivalent to 0. So 5k is equivalent to 5. What is k? It is 5 divided by 5. 5 ones are. So k is equivalent to 1. So the ratio, that was our supposition, k is to 1. Therefore ratio in which the line segment is divided is k is to 1. That is k is equal to 1. That is 1 is to 1. It's very simple. Similarly, question number 6 reads 1, 2, 4, y, x, 6, 3, 5 are the vertices of a parallelogram taken in order. Find x and y. Find x and y. Now it is parallelogram, vertices of a parallelogram. You know the diagonals of a parallelogram bisect each other. When is the parallelogram? Parallelogram means the quadrilateral with opposite sides equal and parallel. Let ABCD be the parallelogram, and A has the coordinates 1, 2, B 4y, and C has the coordinates x6, and D has the coordinates 3, 5. Now, since one property of this parallelogram is that diagonals of a parallelogram bisect each other. Now again we will apply this section formula. But here, when this bisect, when the diagonals bisect each other, that is the sections are equal. This, suppose this O, this AO is equal to OC, and this DO is equal to OB. So both sections are equal. So that is very simple. Now, when we consider this diagonal AC, the coordinates of this point O, coordinates of point O are coordinates of point O are x1 plus x2 by 2 and y1 plus y2 by 2. Similarly, again the coordinates of the same point but this time we will take this diagonal DB. Coordinates of point O taking the diagonal DB is again the same x1 plus x2 by 2, y1 plus y2 by 2. So this is simple very. तो ये एक ही पॉइंट की कोऑर्डिनेट्स है O की. So x1 plus x2 by 2 taking this diagonal AC, and y1 plus y2 by 2 is equivalent x1 plus x2 by 2. Similarly, y1 plus y2 by 2. This is when the sections are equal. So what is x1 here? It is 1 plus x2 is x. x2 is x divided by 2, comma y1. What is y1? It is 2 plus y2 is 6 by 2 is equivalent. x1 this time we are taking this diagonal. This is 4 plus 3 by 2, comma y1, y plus 5 by 2. So this is very simple. X plus 1 by 2